All right, let's try to now create an elastic load balancer, and that's the last piece of the entire puzzle. All right, so let's click on EC2, and once you click EC2, you'll see a lot of options on the left. Earlier we had used the launch instance to create a machine. Now let's select this elastic load balancer from here. So let's select load balancer. All right, once here, let's create a load balancer. Okay, so we'll launch it in my default VPC. Okay, and this will be the load balancer protocol. So it will be using HTTP 8080. Let's name the load balancer as auto scale LB. All right, let's press continue. Under the configure health check, we'll use TCP, and the ping port can be 80. Response timeout. Let's set the health check interval to 10 seconds and healthy threshold to 2. All right, let's press continue. And let's create a new security group and call it as quick create one. That is fine. And let's click on the custom TCP rule that port TCP80 is already permitted, so that's fine. Let's click on continue. It'll ask you if you want to add any of the instances to the load balancer, so we won't select anything. Keep these two options checked and let's press continue. You can leave this section again as blank and say continue, and then it will summarize everything. And then let's click create. Once you've created it, you will see that you will see a new entry here, and under load balancers, the one that we just created. And right now it says that it doesn't have any instances added to it. All right, but we have created an elastic load balancer. The next thing is we'll create a launch configuration. So let's click on launch configuration. Once here, click on create launch configuration. And then the entire process will be quite similar to the one that when we created for instantiating an instance. So let's select Amazon Linux AMI. And for this one, let's select T2 micro. All right. And then let's click on next configure details. Under name, let's say web launch configuration. And let's click on the enable CloudWatch detailed monitoring here. And then expand advanced detail and then enter the script. So enter the script and then press next add storage. Let's select the default option. Once at the security group, you can just say SSH and you can create another loop for HTTP to allow port 80 and then say review. Once you review and everything looks good, let's go ahead and create a launch configuration. Then again, the same thing, you'll choose an existing key pair, we'll say sysadm and then acknowledge it and say create launch configuration. So because we have created a launch configuration, the next logical step is to create a launch group. And so let's say create an auto scaling group using this launch configuration. Let's call this as web group. You can leave the rest of the stuff as defaulted. Let's click on advanced detail. Let's say receive traffic. And remember that we had selected an ELB before. And so we'll select this one here. LCheck type is going to be EC2. So we can just let it be EC2. Next, click on configure scaling policies. Okay, you can select a default VPC here. So we've got both of these two added, and then let's select next. Under here, let's say we just say keep this group at its initial size. Next configure. Can leave everything as blank and click on review, and then it will summarize whatever you've selected. Let's create the auto scaling group. So once the group has been created, let's go to the instances. And right now you will see that there's just one instance which is now initializing right now, and this has been launched as part of this entire setup that we just did. And right now it's initializing, so we'll just let it initialize and do its stuff at the beginning. Okay, so once your machine has started, you will see that it will give you a public IP address. So you just click on it and just try to open another page. And so the moment you see it, that means that everything is working fine. Basically, we've created a dummy website, a dummy application, and if you click on generate load, it's going to increase the CPU load. Also, if you go to your auto scale group, you will see that right now one instance is allocated to this group. And if you click on instances in this auto scaling group, you will see that it lists down the instance which is running for you right now, which is this one. All right. Good thing about this whole thing is once you've got the auto scaling group defined, and if you try to stop one of those instances which are running under auto scaling group, because the desired minimum number is one, it will always make sure that there's one instance running. So let me just try to stop this, and so I'll say stop this instance. Okay, and so I say yes, stop it. So after I've stopped it, you can see that it has not detected this instance as unhealthy, and because it's supposed to keep a minimum, it is supposed to keep a minimum of one instance and maximum of one, which is mean that at all times it's going to maintain one instance. It will now try to spawn another instance automatically. I'm not provisioning it, but it will automatically instantiate one more instance. And so now if you see that after I had stopped it, another instance has now started in its place, and it's up and running. If I go to the IP address, public IP address, if I go here, see that it's running the application which I wanted it to. So now let's add policies to our auto scaling group. Right now it's a very simple scaling group which only allows at the max one instance and at the minimum one instance, which means that on all times one instance will be running. Let's try to modify that auto scale group slightly and create a scaling policy. So let's add a policy to it now. Let's say we create a policy called web scale out. All right. And execute this policy when. So you have to create an alarm. So we'll say create a new alarm. You can actually select a SNS service, and that does is it's actually going to send an automatic email whenever this event happens. So let's just not select it. And then we say that whenever average CPU utilization is greater than 50%, that's when you have to execute, and for at least a consecutive period of 1 minute. So let's say 1 minute here, and this is the automatic alarm name that it has provided us. So we'll just stick with it. Let's call it as I. Let's call this as ICU alarm. All right, and then say create alarm. Okay, so when this alarm has been created, what's the action that you want to do? You have to, and so we'll say that okay, add one instance to it, and then wait 300 seconds before my another scaling activity to happen, and let's create it. Let's add another policy, and this will be more like a scale in policy. So we'll say web scale in, all right, and then we'll create another new alarm. Then let's not select this. When average of CPU utilization is less than 30%, okay, so for at least one consecutive period of 1 minute, and we'll just reduce one instance and we'll call it as low CPU utilization. Then we say create alarm. So this is going to create an alarm for us, and then what we say is remove one instance. Then we press on create. So now we got these two policies in web scale in and web scale out. Web scale out is going to add additional instances, and web scale in is going to remove one instances whenever that's there. One thing important to notice about the group is that with our desired minimum and max is one, so we need to increase that. We won't be able to add additional if that is set to that value. So let's say desired, and let desired be one. Minimum we can set it as one, but maximum we say as five. That's the maximum number of EC2 instances you could have, and then click on save. So now what we have is that we can have maximum five instances, minimum one instances. We've got the scaling policies right now in this group, which say that okay, if the CPU utilization is less than 30%, remove one instance. If it's greater than 50% for a duration of 1 minute, then add another instance. Now what we'll do is we'll go to the instance that is under this web scaling group, and what we'll do is click here. It's going to take us to the menu where it is there and under the EC2, and let's click on the IP address here. It's a small little web application that I created for creating a dummy load to the CPU. So what we'll do is right now, if you see that scaling group, under the scaling group, one that we just we had created for this demonstration. Right now we have instances of one. Okay. Now let me click on generate load. What this is going to do is it's going to bombard the CPU. So right now the CPU load is on 100%. And what this will do is Amazon is tracking this instance, and if it finds that the CPU load is greater than 100, greater than 50% for more than 1 minute, it's going to launch another instance. So let's just keep on refreshing it. At some point, what you will see is that this instance count will increase from 1 to 2. And so after a while, you will see that it has added a second instance. And because the default cooldown period is 300, what it means is that it's going to wait for another 5 minutes before it evaluates the CPU load, which is again it's gone down to 0%. And so it's going to evaluate it again, and then it's going to add additional instances if required. And if it's not required, if the CPU is again utilization goes down below 30%, it's going to remove instances, and then you'll be set to one instance again. There's a good tab here under scaling history, which you can actually view. What it does is it tells you. So if you see that, remember I terminated one of the EC2 instances and then it launched another instance, and see the cause. It says an instance was started in response for a difference between desired and actual capacity, increasing the capacity from 0 to 1. So that's why at that time, because we had the minimum set to 1, it added another instance here because we stopped the only instance that was running, and then now this time it has created another one. And see what it the cause. It says a monitor alarm, high CPU alarm and state alarm triggered policy web scale out, changing the desired capacity from 1 to 2. And instance was started in response for difference between desired and actual capacity, increasing the capacity from 1 to 2. And so that's how your auto scaling works. So it automatically increases the instance count so that you can handle the workload better. One last concept that I wanted to demonstrate was that until now, what I've been doing is I've been taking the IP address of the instance and then opening it here in the web browser for accessing the application. But remember that on top of these instances, we have a elastic load balancer setting that we created previously. So let's click on load balancer. And the concept I want to demonstrate is if you click on auto scale ELB, it basically gives you a DNS name. Now, if you click here and if you copy it and if you open that in the browser, it's going to show the same thing. Now, this ELB is actually right now because there are two instances running under the auto scaling group. It has gone to one of those instances and got me the this particular application. Okay, because there are two instances running, and if you click on instances, you see that we've got one is 7106 and one is 1E380. So I got 7106DD. Let me click on it again. Let me open it again and see this time I got another instance. So basically the load balancer is actually balancing the traffic. One time it's going to this instance, one time it's going to the other instance. So it's basically doing balancing there. If I enter the IP address of this instance, every time I access the application, I'm going to get the same instance ID. Remember that EC2 instance ID identifies the machine on which it's running. All right. So that is all what I wanted to demonstrate. If you have any questions, feel free to reach out to me, and I'll be more than happy to answer. AWS is a very very important concept, very